Throughout section 1.4, we've been evaluating the 6 trigonometric ratios at the common angles, angles that are quadrantal, multiples of 30 degrees or 60 degrees, or multiples of 45 degrees. In section 1.4.6, we'll talk about the non-common angles. We'll approximate the trigonometric functions for those with a calculator. When we have quadrantal angles, multiples of 30 or 60, and multiples of 45 degrees, we will strive to always give the exact values for the trigonometric functions for these angles. We don't ever want to approximate unless it's a required part of the problem or within an application. However, for the other angles that are not as common, we will approximate the trigonometric functions using a calculator. Now, to correctly evaluate these with our calculator, we have to pay attention to the argument of the trig function. Is it in degrees or is it in radians? That will affect how we evaluate it on our calculator. So let's practice evaluating the following trigonometric functions with the calculator, and we are going to round to 4 decimal places. For example A, we want to evaluate sine of 27 degrees. 27 degrees is a quadrant 1 angle, so we can predict that its sine is going to be positive. However, 27 degrees is not a common angle, so we'll evaluate this with our calculator. Let's be sure that our calculator is, first of all, in degree mode. So I'm going to press my mode button, and I'm going to go down to about the 4th line, and I want to be absolutely sure that degree is highlighted. To be sure, I'm going to press enter, and then I'm going to press second quit and go back to the home screen. Now my sine, cosine, and tangent buttons are right there above the comma and the parentheses. So I'm going to access the sine function. It opens parentheses anticipating the argument. So I'm going to type in 27 degrees and I'm going to close parentheses. When I press enter, the calculator spits out the value. So to the nearest 4 decimal places, notice in the 4th decimal place we have a 9, and the 5th decimal place we have another 9. So we're going to need to round up to 0.4540. So we get 0.4540. And I'm also going to do the squiggly equals to indicate I have approximated that value. Now look carefully at example B. We have cosine of 27. This is a distinctly different problem. First of all, we're dealing with a cosine, but also notice in the argument there is no degree symbol. Because there's no degree symbol, we are dealing with 27 radians. So in our calculator, we're going to have to switch over to radian mode. So I'm going to press my mode button. I'm going to go back down to line 4 and press enter to change the mode to radian, and then second quit back to my home screen. Then I'll evaluate cosine of 27 radians. We end up with a negative number 0.2921. So negative 0.2921. Now, just to show you that it's very important that you pay attention to the mode, let's go back and evaluate sine of 27. On part A, we were trying to evaluate sine of 27 degrees. If I enter this while in radian mode, notice I get a completely different answer. So it's important now and later, especially when we're graphing, to make sure we're aware of the mode of our calculator. On example C, we have tangent of 202.8 degrees. For 202.8 degrees, notice that's a quadrant 3 angle. In quadrant 3, tangent is positive. So let's switch our calculator back to degree mode, and then we'll be able to approximate this, knowing that we're anticipating a positive answer. So 202.8, the calculator is going to regard that as degrees, and we get positive 0.4204. 0.4204. Now, just as tricky is example D. When I look at example D, I see 3.14. That is a radian measure. Notice there's no degree symbol. So I'm going to need to switch back over to radian mode. Radian mode. Press enter to ensure that you've changed the mode. and the problem was cosecant of 3.14. Now, there's no cosecant button on the calculator, but remember, cosecant is the reciprocal of sine. So we're going to enter this as 1 divided by sine of 3.14, and that's in radians. 1 divided by sine of 3.14. We get 627.8832. 627.8832. Now, sine and cosine are going to range between -1 and 1. We'll learn that very well when we graph in the next chapter. But secant, cosecant, tangent, and cotangent, it's possible that they have very large values just like this one. The next example is a secant function, and notice we're back to degrees. 3.14, it's tempting to think of that as pi, radians, but because of the degree symbol, we're talking about a very small angle here. So secant of 3.14 degrees. Let's go back to degree mode. Get used to doing that quite a bit. And we want to evaluate secant. Again, there's no secant button on the calculator, but we know that secant is the reciprocal of cosine. So we're going to evaluate 1 divided by cosine of 3.14 degrees, and to 4 decimal places, we get 1.0015. So approximately 1.0015. Keep in mind, I'd get a completely different answer if I were in radian mode. For our last example of the day, we're going to evaluate cotangent of pi over 5. It's an exact angle, but it is not a common angle. So first of all, we need to make sure that we're in radian mode. I'm going to go back and switch it one more time. Then notice there's no cotangent button, so we're going to enter this as the reciprocal of tangent. 1 divided by tangent of secant pi over 5. Close parentheses on the argument every time. We end up with 1.3764. So approximately 1.3764. So it's a simple calculation, but you do have to know a little bit about your calculator. Make sure that you pay attention to the angle. If it's in degrees, make sure you change your calculator to degree mode. If you recognize that either there's no degree symbol or it's a multiple of pi, then make sure that your calculator is in radian mode. Also, for cosecant, secant, and cotangent, remember you're going to have to use your reciprocal identities to type those into your calculator. All right, good job. That completes another section. 1.4 is complete, and you're ready to begin your homework. Good luck to you.